Welcome to the session on systems of ordinary differential equations. In this session, I will discuss on the definition of system of ordinary differential equation, order of the system, homogeneous of the system, normal form of the system of differential equation, linear and non-linear form of the system of differential equations, and finally solution of the system of differential equations. Let's get started. Simply, a system of differential equation consists of two or more differential equations in two or more unknowns. We have given two examples. Here we can see the unknowns are x and y, and this is first order ordinary differential equations, and there are two equations, equation 1 and equation 2. These two equations consist a system of differential equations. In the right side of this each equation, this is function of f of t, and this form of equation is a non-homogeneous form. As we can see, the coefficient of the highest order of the equations is 1, and this system is a normal form. And similarly, the system of equation 2, first order system of linear differential equation in two unknowns functions. The general form of the first order differential equation in two unknown functions is given here. Here is unknown function x and y, and the coefficient of its derivative are all the function of t, and finally f of ft, f1t and f2t is all are the function of t. And this is an example, particular example. And here AIT is all are the function of t or any constant. Now, what is the solution of this system? A solution of the system is an order pair of real function fg such that x is equal to f of t and y is equal to gt. These functions satisfy both equations of the system on some real interval. And first order system linear equation in three unknown functions. Let us see the standard form of this equation. There are three unknown functions x, y and z. This is the standard form, and here we have given an example with the standard form. In the right side is all are the function of t. So there are three unknown functions and three differential equations consist a system of differential equations. This ai all are function of t, and f j all are the function of t or any constant. The solution of the system is an ordered triple of real function f, g and h such that x is equal to f of t, y is equal to these all functions satisfy the system on some real interval. This second order system of linear differential equation of two unknown functions. The standard form of the second order system of two unknown function is given here. X, y are two unknown function. This is the second order, and we already know a1, a2 and f are the function of t or any constant. Here is an example. So what is normal form of the system? For second order system of linear differential equations, the normal form is given here. For the normal form, the coefficient of the highest order derivative term is equal to 1, and this is equal to 1. So if we reduce this system to its normal form, then we will get the normal form. Just we have to divide this equation by 2 and this equation by 3, and we will obtain the corresponding normal form of the system of differential equations. The most important thing is the definition of the system of differential equations. A system of differential equation consisting n differential equations in n independent variables, or this is unknown functions, and these are x1, x2, xn, is of the form this. There are n equations. Observe that this system is a normal form because the coefficient of the highest order derivative is 1 in each equations, and here aij and fi are the function of t or constant, where ij is equal to 1 to n, and homogeneous if fit is equal to 0. If all f is equal to 0, then this system will reduces to a homogeneous form. It is non-homogeneous. Any f from the system is non-zero. Any f for any I, for any I. The given system will be linear. A system of differential equation will be linear if the following conditions are satisfied. The dependent variable xi and its various derivative occurs to the first degree only. No product of xi and or any of its derivatives are present, and no transcendental functions of xi and or its derivatives occur. A nonlinear system. If a system of differential equation is not linear, then it is called the nonlinear system of the differential equations. So what is the solution of the system of differential equation for n unknowns? A solution of the system is an ordered n tuple of the real functions sub to n, such that n is equal to fn t. Simultaneously satisfy all n equations of the system on some real interval. Let us inspect the following system of differential equations in terms of dependent and independent variables, order, degree, homogeneous, non-homogeneous, linear, non-linear, and normality. The number 1, this is a system of differential equations having two unknowns. The order is 1, degree is 1, it is non-homogeneous, it is also linear, it is linear, and no, it is not normal. And the system, it is two unknown variables. This is second order, because this is second order. Degree 1, it is yes, it is non-homogeneous, because we can see that there is a function of t. It is of course linear, and it is normal. Yes, it is normal. For 3, this is two dependent variable, first order, first degree. Homogeneity, it is non-homogeneous because the presence of f of t in both equation. uh, this is linear, yes, this is linear, and this is normal. I think you can solve this. I hope you all understood the system of differential, what is the definition of the system of differential equations, and what is the linearity, homogeneity, order, uh, and solution of the differential equations. Thank you very much.